So let's start with this, that we are talking about this GeoAI. So it was before 2020, there was not a single term was there GeoAI. It came with the introduction of the Sam Altman when they came with the GPTs. Okay, very few institutions, those who are working with the ML models, they are actually use the terms artificial intelligence lot before. But in terms of geography and in terms of any geospatial analysis, GeoAI was not there. So in this presentation, I will not be going and decoding the word GeoAI actually. First, we will be going that why we are so much in this buzzword trend of applications of artificial intelligence and machine learning. Is this because that AI is trending and we all have to follow the trend? That is the first reason. Or is it genuinely helpful for each and every person, those who are trying to enter into this field? So before coming to that, but I just want to spend a very few basic things that why we are actually moving towards machine learning, because there are traditional things like we have MCDM, analytical hierarchical process, we have Topsis method, there are a lot of things, but those that are traditional. But when we want to work something with high precision that can actually scalable, that is something which is not only scalable but reproducible within a very short span of time. That's why we are moving from this conventional geospatial research to the advanced part. So if you just ask me this question, that who am I to talk about this, the thing is that I am practicing this GeoAI since 2022, the time when the GeoAI term was very much vague to the entire geospatial professional domain. So from that to till now, our lab has published 8 to 9 relevant papers working on this geospatial analysis. And I have also have the experience of startup curator. So I visit a lot of new startups. People calls me and I curate the startups also, that how they are using this geospatial part and how actually this entire industry things work. So that's why this 4.5 years of experience that I have, that we as a team that we have actually, we just want to pour in this 2 hour of session so that you can actually understand what are the things that you should do and what are the things you should not do, because we have done a lot of error, we have failed a lot of time, we have done a lot of error, we have had our paper rejections for more than 9 to 10 times during our first attempt. So when we started giving my first paper took 3 to 4 years, and that was the last paper that has been published. So other papers that I've written during this time that came earlier for each and every one in our group. So these are tried and tested experiences, not just buzzword. So I hope you will enjoy this entire presentations. So let's begin, and keep yourself calm, compose, and keep your mind broad open, because we will be showcasing you various multidimensional aspect of this geospatial research. You will find no traditional work here. And one more thing I just want to tell you, last but not the least, that whatever we are presenting, we have done research on this, we have visited the field, we have done each and every research, and then we have come here to give the output to all of you. So basically, when we are traveling from this traditional method to modern GUI method, what we are, the main first thing that we focus is automation. Second thing is predictive modeling, and last but not the least is the scalability. That if I am doing this work, suppose in Himachal Pradesh, can I do the same thing in Jammu and Kashmir, or can I do this, replicate this entire thing into this Uttarakhand? If yes, then it is scalable. So this doing the same thing in different field is known, according to machine learning terminology, is known as transfer learning. So if you have pen and paper with you, please you should note these terminologies, because these terminologies are very much important, because it takes times to understand the terminologies that are associated with the machine learning and geospatial research. So basically what we are doing, how this entire research actually works. This entire research works in this way, like we have satellite imagery, we have IoT sensors. A lot of people work with the physical devices, and then we have social media feeds. Now the interesting question is, what is the social media feeds? When you tell that you are actually feeling safe in an earthquake near prone area, you are actually sending the message of your geospatial coordinate that this area is actually safe. In this way, we are gathering the data, and there is one GeoAI engine where we have all the models together. Nowadays, we don't call it a model, we have a better version of it, we call it AI agents. So nowadays we have agents also, and then through these agents we get the prediction. So what type of predictions we can get? We can get the environmental change monitoring. There are a lot of PhD scholars I can see those are working with the environmental modelers. So this is a very good chance for them to actually automating these environmental monitoring, forecasting, then also bias variance trade-off, and as well as the bias corrections. They can do all these things together here. For you, if you see it, Zomato app, how they work on traffic flow and optimization. For that, they use Dijkstra's algorithm. And then coming to the my field of research, that is disaster management and disaster predictions and disaster responses. So all these things are there. You need to understand that it has varied type of multi-dimensional utility. Now, if we come to the trend of the paper publications, that we can see that from 2016, it has taken a giant leap, because I was using my metadata that when I was started my research. So till 2023, you can see there is a huge exponential growth, and there is a projection also that 2024-25, the growth has also increased. So these things are not buzzword, people are actually working on it. Then it is coming that beyond traditional deep learning methodologies, there are other shifts also, that what type of deep learning methodologies that people are actually using in this geospatial domain. One of the most basic DL models or ML models that are LSTM is there, CNN is there, that is convolution neural network. LSTM is long short term memory. Then we have support vector machine, random forest, everything are there. So this type of models are actually used in this machine learning model till 2025. Now the shifts are also changing. Now we are no more into this machine learning model. We are now moving to the AI agents also. So here we will give you an entire idea how these entire things actually occur. So you can see there are these type of words like landscape susceptibility, flood forecasting, groundwater potential, hyperspectral image classification. All things are now using artificial intelligence to actually predict, and their accuracy are much higher than other traditional model. So this is that from topography to topography, there is an epistemic shift actually, that how this entire market is shifting, because geospatial technology has shifted very fast paced along with the AI technologies. So you can see that what we used to do before, we used to do an overlay analysis. We have a main DEM data. Above that, we are using land cover, soil, rainfall. So when we made an overlay analysis or a TOPSIS model or MCDM system, but now we are shifting. So when we are shifting, I just want to give one example that if you are using AHP, you will find a condition known as expert paradox. Now, what is this expert paradox? When you are using analytical hierarchical process, you have to give the weight. Now, the question is on what basis you are giving weight. For someone tells it is because of my supervisor is expert, but how you can quantify someone as an expert? Or someone can tell that I am using the previous literatures, but previous literature may not comply with today's world. Okay, so past literature, what are the factors are there? At present, there are much more other advanced factors has also come, or advanced preconditioning factors has also come. So for that particular reason, this expert paradox becomes so much ambiguous that these models are always questionable for the reality, that whether it is aligning with the real world or not. So you can see for this reason, there is a lot of stress that is going on around this particular area, and you can see that all these research actually takes a lot of time, but if you build one time this ML model, it can be easily scalable. So for this, we have used this technology to show you that how this traditional GIS and modern GIS are different. Okay, so you can through this entire PPT, you will see that how each and every time we had compared that why we need an ML and DL based application rather than this manual waiting, overlay, static map. We can make much more dynamic maps out of it. So if you see a head-to-head man versus machine, you will see the output predictions of AHP, XGBoost, and deep learnings are quite different. We are using same geospatial factors, but results are different. For example, I can show you, this is one of the results done by one of our assistant professor, Mr. Arup Boidu, has made this entire research. I have just wanted to show the schematic only, that how when applying, we have the same amount of preconditioning factors, but and see the result of an AHP and see the result of a deep learning, how different it is, how perfect the deep learning models are, because it is not giving ambiguous results. They are classifying only the pinpoint precise areas, not the entire area, like a weighted overlay analysis or an analytical hierarchical process analysis. So from this you can understand that what type of predictions this deep learning can provide us. So if you use this type of, if you learn to use this type of model, it will not only help you to publish a paper, but you can also land a good job in industry. So if someone tells you that in today's world that GIS will give you job, that's totally wrong. And if someone is telling you this and selling any courses like this, that GI, if you do some basic GIS, you can easily get a job, no, you will not get a job, because now with a single prompt, entire production analysis can be done. So you have to be better, you have to learn better. So for this, machine learning and deep learning is the first survival round. After that there are a lot of other things, but you have to know these basic things. So you can see that in an image analysis, how these deep learning architectures are actually used. You can see this is an architecture of a deep learning. We have a raw observation, and then we have a predictive classification map. In between this entire process that occurs, that is the machine learning. So before understanding these terminologies, before understanding that how this works, first you need to have a mental map that how this entire thing is working. I have some image, and then I have to put it into some mechanism, and it will give me my final result. So what is this mechanism? What is the mathematics behind the mechanism? What is the statistics behind the mechanism? That is important. So now the current trend, what are the current trends? We have autonomous AI agents. Okay, so I am also building some AI agents that are actually orchestrated with the dynamic improvement of the spatial part, so that we can do spatial research with just with a prompt. Because in AI summit recently I visited that happened in Delhi, there are a lot of companies, they are using just prompt to make the NDVI of a particular area. They don't need to download the band, they don't need to make the polygon, they can just draw the polygon in the entire area, they can directly do this entire thing. So you don't need even a ArcGIS, QGIS or any other GIS software to build this NDVI maps again. So if you think that you will get a job just doing a simple GIS analysis, then I think you are in a wrong foot now. So these are some of the things that the traditional GIS logics are there. Then there is a machine learning. Then there is a deep learning. And at last, we have the AI agents. I will also talk about the AI agents in my further part of the PPT. Let's dive in first that what are the researches that are actually going on. Okay, so from this pixel to people, I just want Mr. Arup Boido to come in front of you. And he is an assistant professor who has relentlessly working on a very good part, that is how traditional models and how modern models actually differ. He has worked both on traditional model and modern model, and he can give you a very good idea that what are the problems that he has faced and how you can learn from this problem. And he will go through his entire research of his PhD in such a way that you can also understand what is the mechanism that is going on. So I just want Mr. Olubodo to please take the dice, and please, everyone, welcome him. And he is also an assistant professor. And let's dive in.
Thank you, Shantan, for giving me the opportunity to tell. So, a very warm welcome to everyone. Okay. So, thank you everyone for joining this session. And I also give thanks to the Darshini Group of Solution and RevoMap Solution for giving me the opportunity to talk. So, I will give a very simple schematic way to how this machine learning and AI help you to in your research journey. Okay. So in traditional way, we will use some multi-criteria decision analysis or AHP. So this method have some biasness. So to overcome the biasness, we have created this AI technique in our research so that our accuracy will be higher. Okay. So for that reason, propose I show you my one of my research that use both machine learning and traditional HP technique. So you will you will compare the both techniques, and which is better you will say, tell after this workshop. So in my study, I works on Sundarban. Sundarban is the UNESCO World Heritage Site. So you see in the map, then this is the southern part of West Bengal. This is the study area. This is the Sundarban UNESCO World Heritage Site. So for my study, I choose this region because this is the very suitable site for ecotourism. Okay, so in this study, normal, this is Sundarban is a biosphere reserve. So this has the three layer, that is the core region, buffer region, and in the transition region. The dark green is the core region, light green is the buffer region, and the yellow is the transition region. So in the present tourist spot, I show in this symbol. This is the present tourist spot. Okay, so present tourist spot are in the most of the in the forest zone. So but that also deplete the environment. Okay, so I propose that tourism should be in the transition zone, so that can also protect the forest and also improve the well-being of the local people. For that reason, I propose that tourism should be in this transition zone. Okay, so for that reason, we develop that ecotourism. So sustainable ecotourism is the alternative way that also helps to for develop tourism in that region and also improve the well-being of the region. So we use machine learning and deep learning method for this. Okay, in the traditional AHP method, we use pairwise comparison metrics that selected by the expert or judgment, but that has some limitation because expert give the judgment, so that judgment may be biased. So for that reason, we choose machine learning. This is the some flaws of AHP, because expert may be biased. One expert cannot judge what is the main criteria for site suitability or any others. So there is a problem of subjectivity. To overcome this subjectivity problem, we need some machine learning method. Okay, so for that reason, we choose also one machine learning and one deep learning method, like XGBoost. XGBoost is a machine learning method, and DLNN is the deep learning method, where we use artificial intelligence and that some type of neural network for calculate predicting the suitable site. Okay, there is no human bias because total thinking process by the machine learning or artificial intelligence that creates the more suitable result for this area. Okay, so this is the methodology of the machine learning method. So in this study, I choose 16 criteria. Okay, and why this criteria is suitable? So to use the suitability, we also done the machine multi-collinearity analysis. So within multi-collinearity analysis, we find that this is the most suitable criteria for this analysis. Okay, after that machine learning, we choose some inventory point based on previous ecotourism site, field survey, Google Earth Pro. So by this, we choose the inventory point. This is the base. Inventory is the base for machine learning algorithm. So after choose the inventory, we train the model, because machine learning we have to give some training points based on previous literature or previous data. Based on previous data, they analyze the previous trend and they propose the future what should be. So inventory is very much essential for prediction. So this is next is the modeling process. We use both three model, AHP, XGBoost, and machine learning. So for comparison, we can compare traditional AHP method and modern XGBoost and deep learning method. And after that, we create the ecotourism potentiality map and also calculate the model validation. Okay, so this is the our variables. We choose several like environmental variable, socioeconomic variable, accessibility, or tourism variable. This is the main variable for ecotourism analysis. Okay, and this is our final map. This is very interesting when you see the map. In the left side, this is the AHP result of AHP, where very high suitable zone are represented by red color. You see that most of the most 50% of the area is treated as very suitable, and green is low suitable. So AHP give the more generalized result. Okay, and when shift to the XGBoost or DLN, you give that more specific result, that give focused result. What is the main suitable point. Here give that very focused area. Red is give very minimal area. So that give more accurate result than traditional HP to modern machine learning method. Here the a complete comparison of the three model. This is the first time I use machine learning and deep learning in ecotourism studies. So and also compared these three model. Okay. So in this model, you will definitely differentiate the result of three model. I also zoom the area. So I zoom this in this area. This is a small area in Canning Town, and this is the three model result. In the first, this is the HP, that whole area is suitable, and second is deep learning. Here you see that how this area also differentiate into three layer, and third is DLNN. So deep learning is more accurately represent the suitability zone. So in this three comparison, you will definitely understand this precise, how precise this machine learning from the traditional method. Okay. So this is the
Actually,
result of three method
hello,
that HP gives approx
hello.
43% area is suitable. So this give the over generalize of that area, and execute gives that 4.63% is suitable, and DLNN 6.22% area is suitable for ecotourism. So machine learning gives more precise result. So that help the um, tourism develop of this area, that uh, machine learning give more precise result. Okay. When we go to the accuracy, that accuracy also give in machine learning is very higher that the traditional HP method. That HP give approx 73% is accuracy, whereas deep learning is approx 91%. So you all of you see that machine learning give more accurate than the traditional method. Okay. So uh,
Hello.
among hello.
Hello, sir. Can you elaborate more about DLNN?
Okay, okay, in
Okay. Actually, we have a dedicated Q&A session, sir.
okay,
So please wait for some time. We'll back to you.
okay. After that my presentation, our expert also give more elaborate in this matter. Okay. So
Okay.
okay, so this method not only give the result, this also give why this result happened. So this also inside what is the black box that drive the sustainability, that give what which method or which criteria give the more, that in the HP or previous method, expert give that some criteria may be suitable, but in machine learning no expert is given, machine give which criteria is more suitable. That in this SHAP model create the distance to tourist spot, the first criteria, or distance to mangrove or distance to river. This is the most suitable criteria that help to identify the most suitable point. So this is not by the expert judgment. This is by the analysis of this machine learning technique that give the also reason, not only give the result, but give also which factor give the most suitable. So this also give this reason also. Okay. And we in the study we also give the ground truth, not only maybe and our model maybe give accurate, but is this in the ground also accurate? So for that reason we also give the ground truth verification, and we also go to this region and find that which area we our model give that also in the ground, that area also the suitable zone. So we compare the result with the ground truth and find that approx 87% area is exactly match with our result to the ground. So we can definitely say that this method is also validated in ground reality. Okay. So this is the strategic implication of our study. So thank you for keep patience with, and for more details our expert team will provide you the brief. Okay. So thank you everyone.
Lot of more things. So as we ended here, and just I just want to mention all of you that what type of applications that we are actually doing. So you can see that there are a lot of cross-domain applications, because what have you now seen is one study area that how in Sundarban like region where tourism plays a very important role, where one of our researchers has applied artificial intelligence in tourism. So similarly, there are cross-domain applications. Okay, for example, in one of my work, I have used this terrain reconstruction. Then in other work, one of our expert has also used the for drought prediction. I have used for landslide predictions, and there is another person who is actually working with us. Is also using very beautifully in the peri-urban and urban infrastructure. So if you are from an urban geography part or any other urban planner or working on the urban field, then you can see that the climate and ecological vulnerability as well as the urban modeling, you can use this type of machine learning and artificial intelligence model. So you can see that we have some foundations, that is, we have some data. And then we are moving into our system that from, for example, we have a DAM data. From that DAM data, we are building various preconditioning factors. Then we are sometimes people use this invest model or any other model. So they can use this entire data structure into the ecosystem monitoring model or any environment monitoring model, and then they find out the final results. But whenever we get that results, if we can introduce that results into a machine learning model to get much more refined, finer output, we can see that through earth system hazards, like I am working on these natural disasters, that is very common nowadays. And next is the humans more systems and modeling society. So I just want to mention a very important thing, that if you think that you are from a human background, social background, and if you think that this PPT, this presentation is not for you, you are extremely wrong, because we have also applied this artificial intelligence in the human sector also. One of our next expert will definitely tell about this. So I just want to give the dice to the Gopal Chaudhary. So till Gopal Chaudhary come, I just want to tell you one more thing, that this presentation is something that will give you an immense potential to work on your research, because you take the ideas from this particular research. If you feel any uncomfortable thing, like you don't know this part, but please you ask me. Okay, you can ask your team, because it is a Q&A session also. Okay, so in that manner we can actually help you and collaborate with you.
And warm welcome to all the participants. Good evening to all of you, and thank you, Sayantan, for providing me the platform. So,
Okay, okay, good.
okay. Now I am continuing. Okay, I am continuing now. So, actually, my research topic is actually focusing on climate change and rural livelihood nexus. In specifically the Ra region in the West Bengal, that is one is the most socioeconomically deprived region in West Bengal. So in recent time, we have seen that there is an enormous amount of research which is actually happening in the domain of climate change and rural livelihood transformation. But actually, they are thinking in a linear way, and actually there is a lack of real life solution. So actually, I picked up the research gap and continued my research. So in the recent time, the climate change actually occurring, and that's why there is actually happening the different types of phenomena like droughts, erratic rainfall, heat waves, flood, and the country like the Southeast Asian country like India, which and Bangladesh, which are actually depending on Indian monsoon, and the particularly those people, those who are dependent solely on agriculture, they are facing problem. And my research actually tried to find out the problem perspective from a solution. So here I tried to measure a key framework, that is climate resilience tipping point framework, to find out the actual problem from with the lens of modern artificial intelligence, and try to develop a solution approach. So next slide, please, Sandan. Yeah, next slide. Yeah. So actually, in my entire research, I tried to find out the agricultural distress zone of the Ra region, and for that, I actually took the 26 variables that is actually visible in the screen, that is exposure, sensitivity, and adaptivity. And I also these factors I have taken from the different sources, and some of the factors here is also presenting that the drought, land degradation, which I actually calculated with the help of artificial intelligence and machine learning. And besides this, the secondary data, I have also collected the primary field data from 420 households uh, based on the using the random sampling method. And I have also used the factors which actually is derived from the primary data. And I have also applied the artificial intelligence and machine learning to find out the agricultural distress zone, the first part of my research. And the second part of my research was due to the agricultural distress or climatic distress, how the people are transforming from the farm to non-farm sector, and what are the major determinants behind farm to non-farm sector. And after the farm to non-farm sector, what is the present status of the livelihood, and what type of solution actually required to uplift their livelihood sustainability. So you can see in this page in the left the factors, the variables I actually used for the agricultural distress, and in the middle you can find out that the variables I actually used to find out the farm to non-farm transformation. And in the last column, you can find out the variables actually I opt to measure their livelihood sustainability and to betterment of their livelihood sustainability for future also. Next slide. Next slide, Santan. Yeah. In this slide, you can see the entire scenario, whatever I have talking prior, how I have actually derived the agricultural distress zone using machine learning and deep learning. So here you can see the entire process. The first thing is the hyperparameter optimization, which is actually required to train the model. And after that, I have used the MLPNN, dense net neural network, one is the subset of deep learning. And I have also used the ensemble deep learning method with the amalgamation of CNN, LSTM, and DFNN. I have used the first time this type of model to predict the agricultural distress. And you can find out that there is a three maps. First is the MLPNN, second is the DLNN, and third is the ensemble deep learning map, which I actually derived from the previous factors. And after that, you can see that here is the confusion matrix, result of confusion matrix, and ROCUC curve. You can find out that the ensemble deep learning method provides the best accuracy to find out the agricultural distress zone in the Ra region. And not only relying on the model, besides these, I have also made a rigorous field survey. You can see here there is some field photography, and I actually find out that the place actually showing in the map, which is exactly also representing the ground scenario also. And in the left you can see here the SAP diagram, which is actually showing that drought proneness is the major main determinants for the agricultural distress in the Ra region. And here you can see in the tabular form also that what is the overall agricultural distress scenario in the Ra region based on three models. And there is a district-wise comparison also of the three models. Next, Santan. This is the most important thing of my research, that the prior research actually measured that the livelihood transformation is occurring due to the climate change or whatever the reason, but they have only relied on the MLR, multinomial logistic regression. But there is a problem in multinomial logistic regression because it thinks in a linear way. That's why we have chosen the MLR as a base model. And after that, we have also considered the MLPNN XGBoost as a machine learning model, and after that we have also make a machine learning ensemble model with the help of support vector classifier, random forest, and decision support classifier. Okay, so here you can see that the based on this model, the machine learning ensemble classifiers is showing the most optimal results, and which is also deriving the most accurate factor, which is actually triggering compelling the rural agricultural livelihood peoples to transform from traditional agricultural to non-farm sector or non-agricultural field. And here you can see that here is also the Shapley additive explanation diagram, which is actually nullified the concept of black box model of the deep learning method or deep learning model. And this model is actually, the SAP diagram is actually showing that which factors is most triggering, is the most responsible factor behind the farm to non-farm transformation. So here you can see that the distance from town, here is a concept of distance decay. So you can find out that the distance from town is the major determinants behind the farm to non-farm transformation. So besides this, we have not only relied on the primary data, because the majority of the researcher or whatever from the academic fraternity, they can rely blindly on the primary data. They can find out that the primary data is the ultimate thing. But the problem is here that whenever we have surveyed, Santam, please go to the next slide. Whenever we go for the survey, we find out that there is different types of biases actually occur during the questionnaire survey. So it's vary from the political biases to human biases. So you can find out that we have not only relied on the primary data, we have, besides this, we have also tried to measure what is the suspicious data and what is the anomalous data from our primary field data. And here is the another important find out, that is the creep component, that is non-linear tripping points. So here we have what we have done. So we have identified the agricultural distress region, and secondly we have measured the which factors is responsible behind farm to non-farm transformation. And after that, we have also measured that after transformation, what is the present status of their livelihood sustainability or livelihood score. And that's why we have developed a multi-dimensional sustainability index based on their socioeconomic and their physical assets, wealth, based on these factors. And after that, we have predicted that if the present scenario exists, then what may be their future scenario of the multidimensional sustainability index. That's why we have used here the multiple models like MLPNN, XGBoost, tap transformer, etc. And after that we find out that here also we have used the Shapley additive explanation diagram, and it is showing that to sustain the livelihood, to sustain their multidimensional sustainability score, the number of earning members is required, means the employment generation is required. In the present scenario, we have surveyed the 6 districts of the Ra region of West Bengal and find out that the majority of the peoples are dependent on the subsidy of government, but the subsidy of the government cannot be provide a sustainable way of livelihood, which is actually primarily discussed in different types of researches and literatures. And we have exactly showing that scenario, which is reflecting in the ground also, that the employment crisis is the major factors, or employment crisis is required to sustain their livelihoods. And after that, based on the 420 data, we have also make we also tried to find out the threshold point. Sandra, please go to the next slide. We have also find out that how many of the inhabitants are below the threshold and how many are of the above the threshold. Please go click on the interactive dashboard. So here you can find out that based on the variables, whatever we have taken, that the percent of RNFE income is actually showing that it is in a coding term. So it is actually elaborating that rural non-farm economy, how inhabitants who previously engaged in agriculture in present scenario, what is his income from the non-farm sector. So here you can see that how whatever variables I have taken and what is their distribution in threshold within 420 household data. Okay, so please go to the next slide, Santan. Yeah, this is the present livelihood profiles of the 420 households in the RAR region, and that's why we have to distribute to find out their livelihood, present livelihood scenario, that how many of the peoples are in previously in agriculture and presently now in agriculture, how many are in transition phase, and how many are of in non-farm sector. So here you can find out that the k-means clustering in the top left of this diagram, which is actually representing what is the distribution of the livelihood, and the second, the MSI distribution, is actually showing that the distribution of intermediate or transition people, the distressed farmers and stable farmers. And after that, it is also a radar plot. I will go next in this part. And after that, you can find out that what is the major variables that are actually required to uplift their livelihood. And this is the uh, in the right you can find out that there is a three different types of diagram. Here you can find out that suppose you think that in a latent place, if a stable farmers, you think that he has a 10 bighas of land, but a farmers who is a small land farmers who has a small capacity of land, but he have not any access of irrigation. So if in a latent space we can provide the irrigation access to every farmers or everyone, then what may be their multidimensional sustainability score. So here you can find out in the right, the uh, last diagram, from the last column, the last diagram, you can find out that what may be their MSI distribution, multidimensional sustainability
Sorry to
distribution after
interrupt
the
you,
irrigation.
Gopala.
So I
Sorry
think
to interrupt.
yeah, I think it's all from my side. Okay, so now I am uh overing to Sayantan. Okay,
Thank you.
thank you, thank
Thank
you.
you, Mr. Gopal, for giving us such an insightful comment on the social aspect of the artificial intelligence. That is one of the few things that very few people has done before, because no one has used the word artificial intelligence or used any type of work like this. So if you are from the social sphere working on the upliftment of the farmers or working on the policy driven system, then you can follow him, and he is doing some tremendous work on this particular field. So due to the shortage of time, I will take not a single moment. I will be giving this dice to Mr. Nilanjan, who has done some tremendous work on the fields of urban and peri-urban space using artificial intelligence. So, Mr. Nilanjan, please take your seat and deliver the lecture.
My basic research work is going on about how we can incorporate geo AI in any urban or peri-urban system. So when we see any urban system, we have to deal with three dimensions over there. First one, we have to understand the evolution of that urban system. The second one, to identify the problem dynamics. What are the problems over that urban system? And the third one, how we incorporate the any planning or policy implementations framework over that area. So in my upcoming slides, uh, I have put on three cases. So the first case is the GeoAI for understanding the urban theories, that is the evolution of peri-urban landscape theory and prospects. Basically here I have given you, I have prepared some figures over there. So this is basically highlight the competition of becoming urban. That theory have been developed by us in our lab, and it is already published in Annals of American Associations of Geographer. So this framework actually utilizes the algorithms like fast ICA, then the XGBoost, then Metropolis Hastings algorithm, then GMM using expectation maximization algorithm, and this is a basic outlay of how we incorporate over that. I am not giving much time over that because we are actually giving so much time in the other slides, so I'm bit very fast. So the next thing is preparing the theoretical landscape with stochastic functionalities. So when you are dealing with the GeoAI, you are first aware of the computational thing, what we call the geocomputation. It is our mother branch, the geocomputation. So in the geocomputation theories, there is two branches. That is one, the probabilistic part, and the next one is the synthetic part. So in the probabilistic part, there is a theory that is the stochastic functionality, which actually covers the probabilistic outlay of any landscape, and it is very much important for to understand any evolution pattern of any urban systems of that. So here we have used bistable and tristable network model. It is a 3D modeling graph to understand the deterministic and stochastic trajectory of a landscape and how it is evolved over time. So this is the case 2, that is GeoAI for analyzing urban system, the evaluating the urbanization induced eco-sensitiveness. So we all know that in our fast-paced society, when any of the emerging urban system is grown, it is actually grown in simultaneously two different ways. Sorry, not two different ways. It is simultaneously growing in a way. The first one is that the concrete is expanded, and the second thing is, in relation of that, the natural landscape is fragmented. So by using these two things, can we analyze other ecological variables like the biomass content, like the LPD, what is called the land productivity dynamics, then the soil organic carbon, what is their state, what is their trajectory, what is their actually degraded, they are actually degraded or not, what is their these stabilities, or are they are neutralized in some way, or they are in some haphazard situation. So it is so in that sense, I have used the DenseNet LSTM framework. You can easily see that DenseNet LSTM framework I have highlighted over there. So this is a very brief outline of what I am doing in the GeoAI for analyzing urban system, or the problems for eco-sensitiveness. The next thing is what we have called that, after identifying the evolution of that urban system, the next thing we have planned to do is that to understand what is the problem in that system. The third thing is, can we implement some planning things to minimize or reduce that vulnerability? So here I have so in this slide I have used the case 3, that is GeoAI for urban planning. That is scenario modeling and visual graphics architecture for micro level plan formulation. So here scenario modeling is the new thing, in not a new thing, but by using the GeoAI, it is quite advanced in its nature. So the scenario modeling deals with what if scenario. Suppose if if the current rate of urban footprint growth is maintained, what will be the ecological sensitiveness of that urban area? This is one type of scenario. And the another scenario is that if in relation to the growing building footprint, if we incorporate some green and blue infrastructure over there, what will be the reduction factor or the improvement factor of the ecological stances? This will be this can be analyzed using the scenario modeling framework. The next thing is I can show you that the visual graphics architecture. This is the computer vision framework utilizes to design your digital twin, and by using we can draw different types of mass model based on our plot requirement. Suppose we want to design a plot based on 15% of the green space availability. So what will be its ratio to GCI, that is green capacity index, what is its index to the carpet index and all. So this is a very brief framework how we can use GeoAI for urban planning. I think this is all from my side. I am. It is over to you, Shayantan. Thank you all for patient.
Okay. So as you have heard a lot about this expert talk on how they have worked. Now I want you actually to dive in something new that you have ever seen in your webinars. Okay. So this is one of the most interesting part. I will showcase you all of my work. So first thing is that I will show you a lot of things. Some published, some unpublished, some are in the manuscript. Okay. So learn from this, understand this entire phenomena, don't learn by heart, and I will just provide you these in the art of a story that what we have done and what I have actually done through this entire my PhD. So how this geo AI actually played a very important role in our lives. So you can see that my first work is that geo AI for landslide predictions and risk assessment in the Himalayas. This is the my first topic that I have worked on, and the first thing is that I have published two papers from this arena only. So what I have done. So if you see that there are a lot of points in this particular map. This is the map of Chamoli districts of Uttarakhand, and you can see that these points are basically the landslide points. So we have some landslide points, and I've collected and I have mentioned some non-landslides point together to make the inventory, because we know that in a machine learning and artificial intelligence, we need a dependent variable or the target. So to get the target, we need to have some inventory, the things that has already happened in the past. So in academics, we see that we learn from the past, we do the work in present, and we predict the future. So we have to learn from the past. So basically, we have collected all the past landslides and we have collected this data. And you can see this is my study area. This is a beautiful map here. And this blue color is the kernel density. You will never find this type of kernel density maps in any study area actually. It actually shows that what is the density of landslides occurrences in my district. So higher the value, higher the color, actually violet color or the purple color is, higher is the density of the landslides present there. So in the study area, what I have done, this is my entire methodology. I have the way other people has also built these preconditioning factors. I have built the preconditioning factors. Along with the building preconditioning factors, what I have done, I have used three different models and I got a three different results. But the thing is that what difference I have made that made this paper actually published in a very good journal of scientific reports. So the thing that I have done here is actually, we know that suppose someone working in dense net neural network model, someone working is multi-layer perceptron, and someone working XGBoost. Each and every model has their own advantages and disadvantages. So why not use the advantages of these models? So what I have done, I have used a simple class 11 and 12 mathematical concept, a set theory, having intersection maps and union maps. That's an overlapping maps actually. So if the high and very high positions or very high predictions of the three different maps are overlapped together, what is the common point? So common point shows the intersection map. You can see it is here. This is this intersection map, and this particular map shows the smallest area with the highest risk of occurrence of landslides. And based on this intersection map only, I actually visited the ground and I have done my field survey there. So how I have done, what I have done, I will show you in the next part. So these are I told you that this is my susceptibility maps, and from the susceptibility maps, you can see that this is the most accurate map, and I have visited in this particular area. And so visiting in this particular area, I will be doing few things. Number one, that is, I will be first showing you that how we have showcased this entire research. See, whatever the predictions I have got, many of this prediction has shown some of the real landslides. So this result actually not only stays in the paper, but is actually implemented on the ground. I have visited this particular area. You can see that is a Google GPS map camera photos, and along with the Google Earth pictures to identify the locations where these particular landslides have occurred based on our prediction map. So now we have done this union and intersection map, and from this what we got a combined map. So these two combined maps are very important, but we will much more focus on this intersection combined map because I have visited some of the places based on this area. Okay, so after visiting these particular places, I found that one thing, that whenever in 2023 I visited this place, I want to show you some real proof of what has actually happened in this area. So the first thing, the first real proof is that I visited this place in 2023, and you can see that I have marked this area in through our union map, that this part, intersection map, that this part it will have a very high landslide area. This is the Patalganga landslide area, because in 2024 a huge landslide occurred in that particular area only. So this actually spatially validated my model. So after that, you can see this is the map. If you see in a great details, you will understand. In 2023, I visited this map. I've taken this picture by my own camera, and these are the photos that have been taken in 2024. Photos have been taken by the news channel and some of the locals, and and one of my locals provided me these images, and I have done this calculation that whether this spatial ensemble is actually working or not. So, so to understand this susceptibility, there are some of the blind spots. Okay. So blind spot is a susceptibility is the only thing that we need to know. We need some risk assessment also. So based on this above map, this entire combined map, I actually visited some of the places in the district, Chamole district, and I found something new. So I visited the Joshimath region. So this is the Joshimath region, and in this map you can see that this is a fresh new landslide that has occurred in this particular area. So what is happening? This is a fresh new landslide, and this landslide will be a recurring landslide, because in the next rainfall time or next monsoon time, this landslide will rapidly increase. So we have to understand that if this is, so this is the actually in geological term we call it a landslide crown. So through this map, we actually identified this landslide crown, which is also falling in a very high zonation of my model. And we have to understand that how many buildings which are below these areas are actually vulnerable. So what I have done, I have used a segment geospatial model. This is an AI based building footprint detection, because there are so much buildings. If we started to do a digitization, then will be a lot of problem. I talked with the Quiseng Hu, the person who has actually made this segment geospatial model popular, and he was probably the first person who has actually used this term quite frequent, that is GeoAI. So I talked with him, he has given a repository, I worked with the repository, I experimented that, and I finally found he has managed to segment these entire building footprints. After that, you can see that this is the way that we actually detect through the SAM model. So there are this much of buildings, and if we need to detect this building through vision learning mechanism, this is the system. So there are a lot of machine. If you ask me, there any other machine learning models are there that actually works on this particular field or not, then I will tell there are a lot. There the YOLO V9 models are there, and we have used a simple segment anything model. After that, you can see that this is actually a socio-spatial vulnerability architecture. So started from the susceptibility maps and coming and arriving at a building level precision is a long journey. So we are not only blindly sitting in a place like an armchair geographer and doing the detection, we are visiting the fields, and we are actually doing some real impact. And whenever we got the result, we actually validated this result with the seismic activities, and we found that there are a lot of buildings in these red colored buildings actually got a crack because of seismic activity present in this area also. So that makes its vulnerability much more further danger. So see, you can see in this way we have managed to prove 3D vulnerability mapping, where the deep red colored buildings are the buildings having cracks, and the pink colored buildings are the buildings which are vulnerable because the landslide crown is above. So this is the animation and schematic diagram of what I have actually done, and you can see these are the buildings that had actually got the cracks. And here in this map, you can also see one blue straight line, that is the lineament, because a fault has been gone under beneath this particular area, and so for this only we got some cracks and seismic activities present in this area. So this way we validated one of the work. Okay, so coming to the next part, this is the final 3D model that I built in this model, really built in this area, because I have marked the heights and we built a 3D model. So this is a type of research that some good journal actually wants, that you provide a 3D model, you provide a digital twin structure, so that people can actually understand and visualize how this entire works happen. So after that, if now the most important thing is that, is this AI structure, or is this Landsat susceptibility scalable? It is definitely scalable. The model that I've used there, I have used the same data structure, same modeling, but in a different study area. This is the Satara district in Maharashtra. I have used the same model, and we got a good research result on the landslides. So based on this, now we are coming to a new part, that after doing the landslide, I found that if I have to work on a multi-hazard, I need a good quality of data. So the quality of digital elevation model that highest I have got from this area is Allos Pulsar Dam, having 12.5 meter resolution, but I want a correct a high resolution model for flood hydrodynamic modeling. So for that, I had to do some new things. That is I have built a super resolution dam, and I can guarantee you, you can search the entire internet in India. Very few people has ever worked on this super resolution dam. Okay, so this paper got in a very prestigious journal of ISPRS, and I have got some very good reviews by writing this or by making the experiments of this paper. So basically, I was having a different dam which has a lot of void, and I have filled the void with machine learning, and then I made a super resolution dam out of it. You can see that I got a high mountain Asia dam from this area, which is an 8-meter resolution, but it has a lot of void. So to clear that particular void, what I have done, I have used a methodology. So you can see this is the topography of an 8-meter HMA dam, that is a high mountain Asia, and below is a sentinel multispectral band. So I have used this multimodal system. You will, because if you are working on this artificial intelligence, you will hear this terminology known as multimodal system. So in this multimodal system, we have the high mountain Asia dam, as well as I've used the sentinel data to actually make the void correction much more precisely. So this is my architecture. This is a CRPAG model that is developed by me. That is, the architectural expertise was built by me, and it is a GAN model, that is a generative adversarial network model. Through this model, we can build a lot of new dam reconstruction theories. So I have done this practically, and it is practically possible also. So this is my model center fusion engine. So it now looks like an hyper reality diagram, but this is very simple. So basically, we have taken two different data. One is the allows pulsar, and another is the sentinel data. Then I have also used my void data, that is the HMA DAM, and using this allows pulsar data, I replicated this data and validated with the sentinel data actually, because sentinel data is a satellite data. So to understand the crevasses, that how we are using not a, how we are using sentinel data, because sentinel data is not a DAM data, but still it has been used to enhance the void accuracy so that we can get a good day out of it. So if you want to see the what are the hyperparameters that actually look like on the ground, so these are the hyperparameters, that what is my input layer, what is my convolution 2D layer, what is my max pooling. So an entire structure has been so shown that how we use these hyperparameter optimizations in this entire work. So now you will see that how the void has been cleared. So you can see the main void here, and you can see the reference in the last one, and you can see how my model CRPAG model has actually filled the void so correctly. There are other models that I've also used, because deep net model or unit model or simplified unit model are pre-trained models. Okay, and my CRPG is not a pre-trained model. I have built this model from the scratch, and I have actually trained this model from the scratch also. So it has given much more better result than any other pre-trained models. So this is the that's why we call it a multi-scale topography, and this CRPAG model has a residual pyramid attention. So this attention blocks actually helps in preserving the edges of the dam, because if there is a valley, we will have some dark edges also based on the sentinel data, and based on this simple concept of remote sensing, we actually reconstructed an entire terrain. So you can also see that what are the other functions that I've used. I'm not going into details that what functions I have used in this entire model, but you just see the difference between what unit is actually producing and what CARPG is actually producing. Our data has given much higher resolution, and higher than unit. So after this building this void, we found that in the void there are still some noises. So how we can eradicate this entire noise? This was another big problem. So to eradicate this entire noise, what we have done based on this data, we have built a super resolution structure out of it. Now, the thing is that this is the model name, that is the DS hat framework. DS hat framework is another algorithmic name that I have provided, because this model has produced a scalable, reproducible algorithm that can do super resolution for any other DAM model. You can see this is a model. We have a resolution of 12.5 or 11.5 meter, and then we have converted this into a super resolution DAM, or we have just converted directly to the super resolution DAM. So you can see this is this is the void spaces high resolution DAM that have been used before, and this is the allows pulsar DAM through which we have actually duplicated, or we use a transfer learning mechanism. So then we have made a spatial gap, that we have a spatial limitations because HMI dam is not available everywhere. So if we train a model based on these Allos Pulsar dam, and then we validate it with this, our void field dam, in this way we can get a super construction dam that can have a global scalability. So we have done that only. So based on this, this is the entire structural blueprint of my area. And after the structural area, I can show you that how much accurate this is. We have a structural similarity index of 0.90, that is almost 90%. The RMSs are very less. Okay, it's a mean absolute error in meters are very less, and it is practically considerable. So based on that, you can see that we have also done some stereo corrections. Those who are from the remote sensing background, they will know what a stereo correction is. And we have managed to do everything in this particular area. And you can see how Sentinel data is actually added with the in the patches, and you can see how the Sentinel data plays an important role from this area. So you can see the dam with the voids, the Sentinel patch, and how the target dam is actually looking after the filling of the voids. So in this way, we have used one gradient loss attention mechanism, that is a physics of a training optimization. It actually helped us to smoothen the graph, because if you see the graph, there are a lot of irregularities. It has actually smoothened the graph and make our dam much more precise. So based on this, we have made some validation and we got some good results out of it. And you can now see the original dam, that is 12.5 meter. If zoomed, and this is my DS head final output that you can see, and I can also show you my real result. This is the real result, that how my dam actually looks like. So I got this result through this entire process. It's a very one of my tough research I've ever done, very complex, and first time I was doing, and no one was there to actually help me. So I have learned a lot of things about the generative adversarial network from this model, that how we can do a terrain reconstructions out of it. So you can see that how our model, the DSI mechanism, is actually smoothing these entire noises. So see how AI is actually helping. We don't have the data, but we are creating data using this artificial intelligence. That is the most important thing that each and everyone should learn out of it. Apart from that, we can show that how this learning system is also is like a transfer learning. We have a regional constraint, we have a DSI solution, and based on this DSI solution, we are doing the error propagation. So after that, we will be now moving to some another set of problem that I faced. So now I have built a dam. So this dam will be used for the flood. But the thing is that my study area is Alakananda river basin. So this Alakananda is a part of a Ganga, and we know that CWC, actually Central Water Commission, actually don't provide the discharge data of the Ganga because it's a transboundary river. So based on this, what we have done, so you can answer, so how if I don't get discharge data, how then I have managed to find the flood of this particular area? So I have again used artificial intelligence, because I got one data in a different region. So first what I have done, downloaded the 10-12 years of ERA 5 reanalysis data. And I have also a scalable parameters for this particular data, that how to build it in my, if you go to my GitHub, you will find a NASA image data entire pipeline. You can download and use it in your study area also. So from that, now luckily I have got some good data because of some connections. I got some good data from the Bajora bridge in the Mandi district of Himachal Pradesh. So my study area was Chamoli, that is in the Uttarakhand, and I got another data that is in a different state, but both has the same Himalayan terrain. So I thought, why not we do a transfer learning mechanism? So based on that next area, what I have done, I have collected a lot of information from that, especially the discharge data, the precipitation data. And see, this is the Bajora plain where I have trained the data, tested the data, and projected the final result in my Joshimat. In this way, if I don't even have the data of the Joshimat region also, I can still use an AI machine learning to create the area of a Joshimat data, which is practically more accurate than a physics-based runoff system, runoff modeling. So I visited this Bajora place, got collected the data, I trained the model, built the model, and trained the model, and then I transferred this entire learning into this Joshimat region. I got the discharge of this area also. So we have used the raw rainfall data, and there are other 8 dynamic factors, like we have used CN proxy, and we have built some discharge data out of it. So the model name was CN, CNN, LSTM architecture. Now, why this model? CN is a curved number-based model. This is a physics-based model. CNN is a convolution neural network, and LSTM is a long short-term memory. So CNN, what actually does? It actually works with this entire spatial part, like the preconditioning factor, and LSTM deals with the entire climate, that is the entire precipitation data for the last 5 to 10 years. So in this way, and CN model is for validation. So in this way, we have used a CN, CNN, LSTM model, and we have built this entire system so that we can do a transfer learning. So you can see that the observed and predicted values of this model, these are more or less close, and we have got an R value of more than 0.89. That is a very huge achievement for us, because the values more than 0.75 is acceptable for a good quality Q1 journal, and we got a value of 0.89. That is a great thing for our work. So in this way, we can show that how we are actually defining the peaks, identifying the anomalies, and we are building our model. So we have made a flood duration behavior, and we have got a very good average Q, that is the discharge of that area. And in this way, we find out. So beyond discharge, we are also supporting connecting these things with the flash flood section, so that we can get a cascading nature, that landslides are occurring, flash floods are occurring because of heavy precipitations also. So this is the physics anchor that I have used. I have used a 1D CNN and a temporal memory of LSTM that I told you before. And so this is the transfer inference in Bajora. That's a different place. In Joshima, it's another place. So we are just transferring the data and building something new out of it. So the curve number proxy is something that we are dividing this entire watershed into few cells, because we require this for an HECRA simulation. In my next few slides, I will show you one real life HECRA simulation, how this water flows in the flood. So now to do this entire work, I have done one more work while working on this Bajora bridge. I have few months ago, there was a lot of cloudbuster occurring in the areas of the Mandi district in the Thunak village. I have taken one village and worked robustly in this particular area. You can see this is just an anatomy of disaster, that how much rainfall has been occurred on June 30 and July 1. It's a huge rainfall. It's a cloudburst like conditions, and it has led to a huge amount of unprecedented flash flood that has occurred in my area. So these are the flood risk analytics data. That is, what are the preconditioning factors that we have taken. We have taken precipitation, topography. We have built the hydraulics in HECRAS 2D and 1D module. People actually use the 1D module, but in this study we have used a 2D module that is much more advanced, and we have got a very good output. And I will show you what output we have got actually. So this was my catchment area where the actually flash flood occurred in this area, and I have built one entire NASA IMERGE data, and based on this data actually I have made a rainfall runoff volume, and based on this you can see that the height of these rainfall events, that on which particular days the rainfall has been very high, and we have got a cloudburst like situation. And now based on one of the data on 29 June I have worked. So this is my entire pipeline, how we can download the IMERGE data. So if you want to download the IMERGE data for your work, it's a very good accurate data from the climate data from the NASA. And you can visit my GitHub page in my area. In my GitHub account, you will find the entire pipeline of it. You can download and use it. Okay. So this is the entire pocket, and this is Thunak pocket, in which particular area has already detected that a cloudburst has happened. And you can see that the pre-rainfall and pre-flood and post-flood scenario. And we have used an HECRAS model. This is the HECRAS 6.7 I have used to build this one. And see, this is the way in which we do the inundation. We have some area, we are building some Manning-Sen values. We are using the topographic routing system, and you can see that HECRAS simulation has gone. I can show you one video out of here also. Let me show you one video here. Okay, so you can see this entire video, that how this HECRAS model has shown that on that particular day, how much amount of flood has occurred in this area. So the red places are actually the highest values, that more than 15 meter per second the speed of the water has gone, and in this manner we can actually simulate the entire scenario that has occurred in the ground. So these are something that are needed to be heard. And based on that data, we have also used some building assessment. We have done this building assessment using that same Vision AI methodology of SAM, and we detected the buildings, and you can see that the buildings fall in these particular areas, that buildings are flooded and buildings are safe. So in this way you can do some production grade research in this multi-hazard phenomena, or in the flood propensity model. And see, these are some micro scale impacts. So you are using remote sensing nowadays for a micro scale impact. That's a big thing. Before, people used to tell that remote sensing is for the big people, for the not for a big people, but for the big area classification. But for a micro area classification, we need this type of act. So after that, this is the diagnostic of what actually damage, and because of the human encroachment, we have found some of the results out of it. You can see the ground truth. I will show you the photos also, that in this way the buildings have been damaged. It's an AI generated image, but these are the ground scenarios that has actually occurred in this particular area. You can see that the entire village got washed out, and these are the pre and post event analysis that you have seen, you're watching. So there was one entire college that's the basement has got washed away. So total estimated loss was huge, 6.2 to 7.8 crore in that particular village, and that's a huge loss. So in the research law, you have to also quantify the loss or quantify the gain to get a good project also. So assessing the amount of money, I mean the loss amount in forms of economic terms is very important. So there, that is the thing that we can actually build a scalable blueprint of the Himalayan resistance throughout these intersections. So these are some of the work that I have done, and apart from that, I have also used this same model for a flood susceptibility modeling in the Mumbai metropolitan region and Chennai metropolitan region. If you want to build this one, it is already in my GitHub account. You can directly use it also if you know how to build it. Otherwise, we are there to help you. So there is one software I have also built. In my past webinars, I've also shown this is a software that I have built to actually find these error analysis. To if you do a susceptibility modeling using machine learning, you will find a lot of error, and to find that error, I've developed this software known as -999 GIS data cleaner. It actually takes the it has the capability to use get a accept this shape file, and it can directly work on a shape file. You don't need to convert in a CSV or any other format. The software has been built by me. It is in my GitHub account only. You can visit and you can easily get this software. You can download and use it for your geospatial research. So these are some of the interfaces of my software. And after that, this is one more thing that is very important, that while working with the geospatial research, we have to understand how sampling methods are actually done. So to work with the sampling method, I just want to tell one thing, that to work with this method, there are a lot of clustered data we sometimes collect. So to remove that biasness of the structured data, I just want to tell you that we can do something else, that I have used a k-means clustering method to actually collect the inventory. So this is a very important step that you should learn, that how to do as entire sampling techniques like k-means clustering, a conditional k-means clustering method. So that's me, that's my research. So this is my LinkedIn account. If you want to follow my LinkedIn account, you can scan here, or you can take a screenshot out of it. I'm giving a one minute time. You can take a screenshot and you can connect with me. And I think it will be very much fruitful if you can. I am very much active in this particular field. So after that, I just want to mention you a lot more thing, that so the next thing that is most important, I will tell you that whatever the algorithms that we all have used are generally inside this particular box only. We have used XGBoost. Majority people have used XGBoost, MLPNN, and DenseNet network. And one of our paper has also used deep and simple learning. So we have expertise in all of this type of working in this type of domains. So this is our
Okay.
publication pre. Yes. Okay.
That
So
QR code is not working.
it is not working. Okay, I will definitely give you my LinkedIn code here in the group actually. Okay, so no issue.
Sure.
Maybe it has changed also, because this was a very old code. Okay, so it has changed. I will definitely share the new one. Okay, sorry for this inconvenience. So this is our journey of this entire PhD, that our lab, geocomputation lab, and our Darshanik Group of Solutions is actually able to made. We have eight publications altogether, and one more is coming in within 1 or 2 months. So in this way we are actually working. And the first paper was the ISRS paper. That is the first paper that when we started working, and this was the last paper that is published. So it took a lot of time of more than 2 to 3 years to get published, but we have learned a lot of things through this entire research. You can see all these research are from different domain. It is not like that we have learned one thing and use it in every other aspect. We have done different works, you can see. Okay, so we know what are industry standards, because we are there, we are connecting the industry. I have a lot of people those are in the startup, and we all know that what industry requires. So that's why I wanted to show you people that what actually you should fail, not fail in a trap. And very soon I think we will be launching one course to actually, because see, in a 2 hours of webinar we cannot showcase everything that's beyond this about 2 hours webinar, because the entire 2 years of work, if I have to break everything and show you with hands-on training, I can definitely guarantee you within very short time we will be launching an entire detailed course decoding one of our papers that has actually been published, so that you can actually first start learning the basic part of this artificial intelligence. Like you will be learning the Python, you will be learning the entire pipeline. See, majority people will take a big names, like they will take a name like Python, random forest, PyTorch, a lot of things. But these illusions are not important. You need to build one single pipeline. You don't need a deep learning also. If you can build one pipeline based on XGBoost model, that runs, that is industry standard. But just going into this buzzword that is enhanced by the chat GPT or any other LLMs, and you find, okay, this looks so fascinating, don't go over fascinations, because that's why we introduce this 2 hour lecture to showcase you what are the today's industry standard. Next time you visit any of these webinars, wherever in the entire India or entire world, please keep this particular webinar, make it this the standard. And now then if you compare with others, you will see that what they are trying to sell is just a buzzword. Okay, don't directly jump into this. So this is the real GeoAI, which is fundamentally practical and experimental. You have some data, you will make an algorithmic model, you will then provide a map. This is the Indian architecture. Nowadays, we are not even going this, we are making it live. Like we are using AI agents to make it a real-time data structures also. So these are the some of the skill gaps that we can actually find among the students. So basically the skill gap that we actually showcasing is that the master students, if they learn this type of things, what they can happen, that for the master student, if you can learn, I can definitely guarantee you, you can get any PhD anywhere in entire India. A lot of supervisors also don't know this type of things, but the professors don't know this type of things, because this is quite evident that these are something new. And as we are the students now, we are the scholars now, and we are the professionals, it's high time for us to actually work on this type of work, so that we can build a better sustainable GIS futures for our studies. Okay, for PhD scholars, if you learn this, then publications will be easy, and you can actually differentiate yourselves from the others when in terms of webinars, in terms of academic meets, and in terms of any other conferences. And for the GIS professionals, if you want to uplift your living standards, if you want to uplift your promotion, then please learn this. This is something game changer for you, because you're already in the industry, you know what is required. And if you learn this time, and this is some of the most fascinating thing that you can do now to uplift your living standards. So we are also thinking to actually introduce some real world hands-on GeoIA training. We are not disclosing the dates, because we actually want some feedbacks from you people also. So whatever we will be building, it is 10 to 20% theory, and we have an end-to-end mastery sessions. So I just want to stop here for a few minutes, and I just want to ask the review map solutions to, if they want to tell anything regarding this or not at present, and what is their present thinking regarding this course, if we want to launch it or not. So we don't have fixed any dates, but we are actually trying to build something so that it can actually facilitate, so that we can you can also give value to these 2 hours of hard work that what we are actually doing. So now the dice is going to the review map solutions. Please, the dice is yours. Please tell something about whatever we are talking about. Okay, so if we launch the course, we will probably teach them this part, that is the how we make a data preparations of GIS foundations, and then how the Python geospatial processing will be done, what will be done, the feature extraction, GeoPandas, raster, all the libraries that are required for a geospatial domains that are important. And third part is the spatial machine learning predictions. So we will be teaching everything in details. You can see that these are some of the broad categories, and we will dive down into very deepening part. Like this is the first section, that selections of data sources, how we are selecting, what we are converting, how we are converting. Number two is the terrain analysis, what type of terrain analysis we are giving. And number three is the what are the ML preparation maps that we will be making. After that, we will be diving into these Pythons, that how we will be using GeoPandas, raster, and GDAL. If you are not familiar with the terms, don't get scared. We will teach you everything, and we'll also teach you data pre-processing steps, integrations, and validations. If you want to, thing is that in very next few months, you will be having your internships. If you know all these things, and then it will be a boom for you to get a very good even paid internships also. And those who students, because in September, October, November, at the time when people apply for the PhDs, and if you can showcase that you have learned this type of things, nobody can stop you from getting a PhD. And person, those who are already in a PhD, is a very high time you can make some good paper out of it. So learn this type of things, and it will help you to publish some good papers like us. So these are some of the third part of the spatial machine learning and predictive modeling that we will doing. We will be building machine learning algorithms, then we will do some model development and hyperparameter optimizations. Then we will be making some accuracy maps that are then here we will enhance your skills on the statistical basis. And last is how we are making the map and integrating this entire thing, like from GIS to Python, and then again back to GS, how we are doing this entire thing, how we are orchestrating, how we are replicating. That's the thing. And last but not the least, I have some books that I can share with all of you, because when we launch the course, I will provide you with all these books. So now the world is changing. You have to stay with the pace of technology and work in this field, because geospatial technology is actually shrinking a lot, and GeoAI is evolving. And don't fall into any trap that we will provide you this course, that course. Don't fall into the buzzword. First, see there what they're actually working. If anyone approaches you, tell them what you have actually made, what is the publication, what is this and that, then join the course. Okay, that's why we showcase you what we are doing, how we are doing, and what we will do in future. So first try and test, and then jump. Okay, don't jump for the trap. And there are a lot of, because I we made this webinar for this purpose, because we are seeing each and every new webinars are coming, and they are only filled with buzzword. One of our students actually joined that particular course, and he was telling that pura paisa barbad. Okay, so that's why we came up with a solution to avoid the students that what is the industry standard. So take this as a standard for next few months, and you will understand that what others are doing. Okay, don't fall into any traps. Thank you, everyone.